In in this lecture, I have to explain about two cavity klystron amplifier. So the contents of this lecture is, first one is what is two cavity klystron amplifier and the construction of two cavity klystron amplifier and its operation and performance characteristics and applications. These are the contents we have to learn in this lecture. Two cavity klystron amplifier. So here, what is two cavity klystron amplifier? Two cavity Klystron amplifier is nothing but it is a microwave amplifier which is used to increase the strength of the microwave signals. So here, first of all, we'll see the construction of two cavity Klystron amplifier. This is the simple schematic diagram of two cavity Klystron amplifier. And here first one is buncher cavity, and here we are using two cavities here. First one is buncher cavity and second one is catcher cavity, and the cathode and anode and collector. So first of all we see cathode. Here cathode is used to produce the electrons, which will generate the electrons, and here anode is used to focus the electrons which are injected from the cathode, and collector is used to terminate the electron beam at the end of the catcher cavity. Here buncher cavity is also called as input cavity, and here why it is called as input cavity means because here we are applying RF input at buncher cavity. So we are applying input at buncher cavity, so that's why it is called as input cavity and also called as buncher cavity. And why it is named as buncher cavity means here the electron bunching takes place at the buncher cavity, so that's why it is also called as buncher cavity. And next one is catcher cavity. Here catcher cavity is also called as output cavity. Why? Because we are taking the output at the catcher cavity, that is RF output. We are taking the after amplifying the RF input signal, we are taking the RF output at catcher cavity. So that's why it is also called as output cavity and also called as catcher cavity. Why it is called as catcher cavity means it is catching the output, RF output. So that's why it is called the catcher cavity. It catches the energy of the electron beam. So that's why it is called as catcher cavity, and this is the L is the distance between buncher cavity and catcher cavity, and here we are applying the VC voltage which is applied between anode and buncher cavity, and we also applied V0 voltage which is applied between cathode and buncher cavity. And this is the simple construction of two cavity klystron amplifier, and this is a velocity V0 up to buncher cavity, velocity of electron beam up to buncher cavity, and V of T1 is the velocity of electron beam after the passes through the buncher cavity, and V of T2 is the velocity of the electron beam after at the before entering the catcher cavity. And this is the scale, distance scale and time scale. Here this distance scales and time scale indicates the how much the electron beam passes between catcher cavity and buncher cavity, and time scale indicates that at t naught time the electron beam reaches to buncher cavity, and at t1 it completes the and it passes through the buncher cavity and it leaves the buncher cavity at t1, and it reaches the catcher cavity at T2 time, and again it leaves the catcher cavity at T3 time. So this is about distance, this is the time scale, and this is the distance covered by the electron beam. So up to here it covers V distance, and up to here it covers D distance and L plus D and L plus 2D. Why? Because the distance up to here is L. So and the space between buncher cavity and catcher cavity is drift space. I hope that everyone understand that construction of two cavity klystron amplifier. Coming to the operation of the two cavity klystron amplifier, two cavity klystron amplifier is a widely used microwave amplifier, and it operates on the principles of velocity and current modulation. Here All electrons injected from the cathode arrive at the anode with uniform velocity. Those electrons passing through the first cavity with uniform velocity, and those passing through the positive half cycles of the RF input undergoes increase in velocity, and those passing through the negative half cycles undergo a decrease in velocity. As a result of these actions, the electrons gradually travel around the drift space. The variation in electron velocity is known as velocity modulation. And the density of the electrons in the second cavity gap varies with time. The electron beam contains an AC component now, and it is said to be current modulated. Now the operation of the two cavity klystron amplifier, I already said that cathode injected, the electrons are injected from the cathode, which reaches the at the first cavity, that is buncher cavity. Here in the buncher cavity we are applying RF input, which has both positive half cycle and negative half cycle. As I said that when the electron beam passes through the positive half cycle of the RF input, the velocity of the electron beam is increasing. When the electron beam passes through the negative half cycle of the negative half cycle of the RF input, the velocity of the electron beam is increasing. Because of the variation in the velocity of the electron beam, the bunching will takes place. The maximum bunching takes place at the drift space, and because of this bunching and what is velocity modulation? Velocity modulation means here the velocity of the electron beam will varies, so that's why it is called as velocity modulation. And here at the catcher cavity, the density of the electrons varies with the time, so that means where the signal varies with time is nothing but a AC signal. So it has AC component, so that why it is called as current modulation. And finally the electron bunch, because of the bunching, the strength of the RF signal is increasing. It will takes the output at the catcher cavity. So this is a simple operation of two cavity klystron amplifier. The performance characteristics of the two cavity klystron amplifier is that it has efficiency up to 30 to 40% practically, and it has 58% efficiency, that is theoretically. And the power output of the klystron amplifier is up to 500 kilowatts, and the power gain of the two cavity klystron amplifier is up to 30 dB, and the bandwidth of the two cavity klystron amplifier is 10 to 60 megahertz, and the frequency is 0.25 GHz to 100 GHz. It is the frequency range of microwave frequencies. So that's why it is called as microwave amplifier. These are the performance characteristics of the two cavity klystron amplifier. Of two cavity klystron amplifier is, first of all, these are used in UHF TV transmitters and troposphere scatter transmitters and satellite communication and radar systems. These are the applications of two cavity klystron amplifier. These are used in satellite communications, radar systems and tropospheric scatter transmitters and UHF TV transmitters. UHF is nothing but ultra high frequency TV transmitters. These are the some of the applications of two cavity klystron amplifier.